else we need to discuss about the graph. Already, every 10th class student, they already thoroughly communicated with graphs. Okay, they know that. Now, here we need to know graph. Graph details we need to know first of all. Okay, what is the graph? It is the by the graphical representation we can form the relations. Okay, graphs are used to form relations. We are using graphs for the to form the relations between the two different criterias. Okay, like stress, strain, or we can say the for the x and y. Okay, and the price and the demand. Like this, we are representing this criteria and how the fluctuations are going on. These all things are denoted on the graphs. Okay, these graphs are used to form the relations between the two different variables. Okay, these variables are variable means it varies every time. What is variable? Variable means it varies with time. What is the meaning of the variable? Variable is nothing but it varies with time. Okay, that means varies is nothing but change. Okay, varies is nothing but it is change. The value of the contents will be changed with respect to the time. Okay, that is we call it as variable. Variable is nothing but it varies with time. That means it changes with time. Now we are denoting two variables, that is x and y variables. Okay, x and y variables on the graph. We can say that is x axis here and y axis here. Y axis is the inclined one. This is x axis, that is the horizontal one. On this x y variables we can draw the graph with respect or with related with the x and y variable values. Okay, now here how the graph is will be. Okay, how graph will be we need to know first. If I take some boxes, for example, I am taking only 3 boxes in the graph. For example, you can see this light of like this graph representation. How the graph will be in your notebook, you can check. This is the graph, like this is there. Okay, like this graph is there, right? Now if I take one box of the graph, for example, if I take one box, you can see the one box of the graph. What is the size of this graph? This is 1 centimeter. 1 centimeter. One box size is 1 centimeter. This is also 1 centimeter. This is the square one. What is this? This is the square one in the graph. If we are taking this one box of the graph is 1 centimeter into 1 centimeter, simply 1 centimeter square. Okay, 1 centimeter square is the area of the graph. 1 centimeter square is the area of the graph. If I take this is, you can see 10 divisions, means 10 lines, 10 divisions in one box. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, and this last one is the 10. Total 10 divisions means 10 spaces. You can see this is one space, Okay, second space, third space, fourth space, fifth, sixth, seventh, eighth, ninth, 10. Total 10 spaces are there. That means 10 divisions we are dividing, 10 divisions horizontally. These lines are extending from here. Okay. Now, in the vertical system, same like that, 10 divisions are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this last one is the 10. Total 10 divisions are divided. When we take when we take 15 centimeter scale, 0 to 15 centimeter scale is there in your compass box. You can see 15 centimeter scale. 1, 2, 3, 4, 5, like this divisions are there on your compass 15 centimeter scale. Each one means here 1 centimeter. This is the 0 is starting of the scale. For example, here is the 1. Here what happened? 10 divisions are there on your scale. Listen carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this last one is the 10. 10 is on 1. Okay. Now here on the 5, 1, 2, 3, 4, 5. Here 5, there is a extra line is also there. That means this 1 centimeter, this is 1 centimeter scale. On the scale 1 centimeter is there na. 10 divisions means here 1 centimeter is dividing into 10 millimeters. Dividing into 10 millimeters, because 1 centimeter equal to 10 millimeters. 1 centimeter equal to 10 millimeters. That's why we are dividing into 10 divisions. Each division 1 millimeter. Okay, 1 centimeter is 10 millimeters. Each division is 1 millimeter. 1, 2, 3, total 10 millimeters. 10 millimeters is nothing but 1 centimeter. Each division is 1 division equal to 1 mm. That is nothing but 1 millimeter. Okay, 1 division is nothing but 1 millimeter. Okay, right. Now, here also same thing on the graph. 1 division is 1 millimeter. 1 division is 1 millimeter. On the 5, after 5 divisions, in the graph, total box, after 5 divisions, there is a light line is there. You can observe in the graph, there is a light line. There is a light line, that is the 5 mm line. Here total box is the 1 centimeter. The half of the box is 5 millimeter. Here also in the horizontal also there is a light line is there that indicates 5 millimeter. 5 millimeter for the each and every box. 5 millimeter. Here 5 millimeter and 5 millimeter. Light. Okay, light line is there. That is 5 millimeter. Here also 5 millimeter. This total box is 1 centimeter. This total box is also 1 centimeter. This total one we consider it as 1 unit. We can say this total one we consider it as 1 unit. Okay, one box in the graph we consider it as 1 unit. Okay, understood my point? This is the total centimeter. If I take one big box in the graph, it is, what is the area of the graph? Area is nothing but length into breadth. Okay, this is a square. Here 1 centimeter, here 1 centimeter. Square is, area of the square is a square. That's why 1 into 1, 1 square, that means 1. 1 square is nothing but 1. Area is 1 centimeter square. What is the area of the one box is 1 centimeter square. Area of the one box of the graph is 1 centimeter square. And very minor one, if I take very little and very small piece in the graph, for example, this one division, one very small similar division is, if I take this small division, that means in this we have divided 10 divisions, here also 10 divisions also there. In that, if I take one division on out, this one division on out, what happened? One division is 1 millimeter, right? One division is, if I take one division is 1 millimeter here, 1 millimeter here. What is the area of the this square? 1 millimeter into 1 millimeter, 1 millimeter square. This is 1 millimeter square. This smallest division of the graph is 1 millimeter square. One box, okay, for the every box area of the graph is 1 centimeter square. You need to remember this one. 1 centimeter divided into total 10 divisions. Each division is 1 millimeter. Okay, that's why 10 millimeter equal to 1 centimeter. You need to know this one before we are going to the polynomials chapter. Okay, now unit conversion. Unit conversion. We can see on the road there is a kilometer stones on that 9 kilometers to the Warangal or 155 kilometers to the Warangal, like that kilometer stones are there. You can observe on beside of the roads. Okay, there is a kilometer like that right now. For the distance, unit conversion for distance measurement. Unit conversion for the distance measurement. Okay, now 1 kilometer, for example, the least one, the smallest unit in the measurement is millimeter. Smallest unit in the measurement is 1 millimeter. Okay, 1 millimeter is the smallest measurement of the distance. Okay, smallest measurement of distance is 1 millimeter. Okay, largest one is kilometer, we can say. Here, 1 kilometer means 1000 meters. 1 kilometer means 1000 meters. Okay, 1 kilometer is 1000 meters. 1000 meters అయితే 1 kilometer పోయినట్టు లెక్క. Now, 1 meter అంటే ఎంత? 1 meter means 100 centimeter. 1 meter means 100 centimeters. మనం కామన్గా when we are buying the electric wire, 2 meters, 3 meters wire, or any like a chains, a 5 meter chain, or a cloth, 6 meter cloth, like that we are measuring. Okay, that is in the meters normally. So 100 centimeters is the 1 meter. If you have 30 centimeter scale, large scale is there na, 30, 30, 30, 90 and then 10 centimeters, that will form 100 centimeter. 100 centimeter is nothing but 1 meter. Okay, next, 1 centimeter equal to 10 millimeter. 1 centimeter equal to 10 millimeter. Here, one box is 10 centimeter. We are dividing into 10 divisions. Each division is 1 millimeter. That's why it's a 1 centimeter equal to 10 millimeters. How we need to convert from kilometer to meter, meter to centimeter, millimeter to kilometer, like this. Okay, now see, for example, 2.5 kilometers are there. Okay, 2.5 kilometers are there. I want to convert this into centimeters. I want to convert this into centimeters, for example. So, kilometer to centimeter. See, listen. Kilometer to centimeter. 2.5 kilometers, how much? What you know, 1 kilometer is 1000 meters. 1 meter is 100 centimeter. See, 1 kilometer is 1000 meters. 1 kilometer is 1000 meters. Here 1 meter is how much? We consider it as 1 meter, for example. 1 meter is 100 centimeter. So instead of meter, multiple. 1 meter is 100 centimeter. 100 centimeter. 1 kilometer means 1000 and this 100. Out of, that's a 1 lakh. 1 lakh centimeters. Okay. 1 lakh centimeters. 1 kilometer is 1 lakh centimeters. So 1 kilometer is 1 lakh centimeter. Then what is for 2.5 kilometers? Enta unknown value consider as A. Take into the cross multiplication. 2.5 into 1 lakh equal to 1 into A is nothing but A. If we take 2.5 is there. If we are taking towards the right side, what happens? 0 will cut. 1 0 will cut. So 25 into 4 zeros. Okay. 25 4 zeros. Okay. 3 4 zeros is the A. That means 2,50,000 in the 2,50,000 centimeter. 2.5 kilometers is nothing but 2,50,000 centimeters. You can take like this, or simply if you want to change from larger unit to smaller unit, we need to multiple. 2.5 kilometer to meter I want, for example. 2.5. What is 1 kilometer here? Kilometer is nothing but consider it as 1 kilometer. 1 kilometer means 1000 meters. So into 1000 meters. 2500 meters. Okay, 2500 meters. For example, 200 meters are there. I want in kilometer. If it is reverse conversion, smaller to larger, we need to divide. Here, see, 200 meter to kilometer we want. 200 into. Okay, here we need to, what we need to do? Division. 1 meter is there now here. Meter is there here. Kilometer divided by 1000. Okay, kilometer 1 is there here. Here 1000 is there. I want what is 1 meter? In the 1 meter we need what? We need 1000. Sorry. Okay, what is 1 by 1000 kilometer? So 1 by 1000 kilometer. Chumki 2 by 10. That means 0.2 kilometer. Okay, 0.2 kilometers. 0.2 kilometers. Okay, 200 meters is nothing but 0.2 kilometers. Like this, we need to convert from the one unit to the another unit. These are very important while we are measuring the distances. If I take this graph, we need to represent x-axis and y-axis. Before we are going to any question or any problem, we need to center. మొత్తం బాక్సులు ఎన్ని ఉన్నాయో కౌంట్ చేయండి. హారిజాంటల్ అండ్ వర్టికల్గా. ఓకే, హారిజాంటల్గా సెంటర్ బాక్స్ ఉంటుంది కదా, ఈ బాక్స్ ఈ బాక్స్ ఇది ఉంది కదా, లైన్ ఉంటుంది. ఓకేనా, బాక్స్ డివిజన్ లైన్స్ ఉంటాయి కదా, ఈ బాక్స్ డివిజన్ లైన్స్లో ఏదో ఒక డివిజన్ లైన్ తీసుకోండి. సెంటర్లో ఉన్నది ఏదైనా, అటు ఇటు అయినా పర్లేదు. ఓకే, ఇట్స్ నాట్ ఏ ఆర్డర్. ఓకే, if for example if it is this one, this as y-axis, write as y-axis at one side is enough. Okay, then horizontal almost center we need to take. This is x-axis, represent with x-axis. On vertical line is y-axis and this horizontal line is x-axis. This is y-axis. Why I am targeting this? You need to remember that from the chapter called polynomials, you will get in the final marks 8 to 10 marks. 8 to 10 marks you will get. You will get 8 to 10 marks in the final exam. Be carefully, prepare well for the final exams. Okay, now x-axis and y-axis. For example, if I have, this is the road. For example, this is the road. The distance of the road is 2.5 kilometer, for example. Okay, or 2 kilometer take 2 kilometer. The paper is not 2 kilometers. Okay, paper is not 2 kilometers. How we can represent on the graph? We need to take scale. We need to take scale to represent distance on the ground onto the plan. This is simply nothing but it's a plan. Graph is nothing but simply it is a plan. If we want to draw our graphical representation of the ground, we need to take it as a scale. That means here on the for the every graph, here top right corner, listen carefully, top right corner we need to mention scale. We need to mention scale. Here we need to write scale. I am writing here, listen, scale. You need to write here top right corner. Okay, scale on y-axis, for example, and x-axis. So that x-axis, y-axis. What is the scale for x-axis? What is scale for y-axis? This is the road is 2 kilometers from this point to this point, for example. Okay, and another thing is there is another road is like this. There is another road is like this. This distance is 3 kilometers, for example, from here to here. Okay, now how we need to represent? We cannot represent this 2 kilometer distance on that. That's why we are taking scale. What is scale? Listen carefully. Scale means distance on the plan to the distance on the ground. Distance on the plan to distance on the ground. Distance on the plan. Plan lo enta 1 centimeter anukuntunna. On the plan 1 centimeter equal to, that's why 1 by, on the plan 1 centimeter equal to distance on the ground is 1 kilometer anukuntunna. I consider it as distance on the ground is 1 kilometer. 1 centimeter on the graph or the plan is 1 kilometer. 1 kilometer on the ground అనుకుంటున్నా. That means 1 kilometer for example ground లో ఉంటే నేనేం చేస్తా 1 centimeter లైన్ డ్రా చేస్తా. ఏం చేయాలి? What we need to do? We need to draw 1 centimeter line on the graph. This 1 centimeter line represents 1 kilometer on the ground. 1 kilometer on the ground. 1 centimeter is 1 centimeter divided by 1 kilometer. It represents, we can write it as in the ratio, that is 1:, or we can say 1 centimeter east. Okay, or 1 centimeter equal to 1 centimeter is nothing but this one, or we can write 1 unit also. Okay, this is 1 centimeter is nothing but 1 unit equal to 1 kilometer. 1 centimeter equal to 1 kilometer. In the place of centimeter, we can write 1 unit. 1 unit equal to 1 kilometer. For on the y-axis, you can take same same scale, or you can change scale also. Okay, for example, here 2 centimeter, 2 centimeter on the graph represents 1 kilometer. 2 centimeters on the graph represents 1 kilometer on the ground coach. Okay, or we can say another thing. 1 unit is nothing but 1 centimeter equal to 2 kilometer అనుకుంటున్నా directly I am assuming that y-axis 1 unit equal to 2 kilometers. From that I am writing here, listen, 1 centimeter equal to 1 kilometer in x-axis. That is horizontal. This is horizontal is 2 kilometer road. So 1 centimeter 1 kilometer. So 1 2. This is the 2 kilometer road. AB. Now on the y-axis 1 unit is 2 kilometer. 1 on y-axis, this 1 unit means this 1 centimeter is 2 kilometer. Here what is there? 3 kilometer. Okay, for example, now 1 unit is 2 kilometers completed. If another 1 unit, what happened? 2 and another 2. 2 to 4 aitadi. So what we need to? We need 3 only. 3 means what happened? This 1 unit is 2 kilometer. What is half unit? Half unit will be 1 kilometer. That's why this is 1 kilometer, this 2 kilometer. 2 and 1, 3. Till here. Till here we need to write. That is 3 kilometer. 3 kilometer distance. 3 kilometer distance. Okay. Scale x-axis, how we are taking 1 unit or nothing but 1 centimeter is 1 kilometer. On y-axis I am taking this 1 unit is equal to 2 kilometer. Okay. How we need to draw and x and y axis on graph? For example, here this point is denoted with O. Central point is denoted with O. O is nothing but origin. Okay, now this central point is denoted with O, that is origin. That means here what is the value? 0, 0. 0, 0. 0, 0. That means on x and y, this is the starting point 0, 0. On x axis also 0 and on y axis also 0. Now, okay, x axis 0 and y axis 0. For example, here 1 unit is 1 kilometer on x axis. So 1, 2, 3, 4, like this we need to write numbers. On y axis 1 unit is 2 kilometer. So for every one box in the graph, 2, 1 unit is 2. 1 unit is 2 kilometers. That's why 2. Next to plus 2, 4, plus 2, 6, 8, 10. Like this we need to write. Okay. In the coordinate geometry, x-axis and y-axis, this is like this. Okay. Okay. Now this is first quadrant we are taking. Okay. First quadrant. This is second quadrant. This is third quadrant. This is fourth quadrant. How the signs are there? Here plus, listen, here plus, here plus. Towards the right side plus, toward top is plus. అంటే మనం ఎత్తు పెరిగిన కొద్దీ మన హైట్ పెరుగుతూ ఉంటుంది అన్నమాట. తగ్గిన కొద్దీ తగ్గుతూ ఉంటుంది. సో ఇది తగ్గుతూ ఉంటుంది అంటే మైనస్. ముందుకు పోతా అంటే మన డిస్టెన్స్ పెరుగుతుంది, వెనకకు పోతా అంటే మన డిస్టెన్స్ తగ్గుతుంది. కాబట్టి ముందుకు పోతా అంటే పెరిగింది ప్లస్, వెనకకు పోతా అంటే తగ్గుతుంది, సో మైనస్. ఓకే, ఫస్ట్ క్వాడ్రంట్ ఏ సైన్ ఉందమ్మా? ఎక్స్ యాక్సిస్ ప్లస్, y-axis plus. సెకండ్ క్వాడ్రంట్లో x-axis minus, y-axis plus. On third quadrant, x-axis minus, y-axis also minus. And the fourth quadrant, x-axis plus, y-axis minus. Okay, all about these quadrants in the coordinate geometry. We need to know how the representation of positive and ఓకే, ముందుకు పోతా అంటే పాజిటివ్, ఇంకా పోతా అంటే వెనకకు తగ్గుతూ ఉంటుంది, పైకి పోతా అంటే పెరుగుతాం, కిందికి పోతా అంటే తగ్గుతాం. దట్స్ వై హియర్ సి ప్లస్ ప్లస్ మైనస్ మైనస్. ఆన్ దిస్ క్రైటీరియా వీ కెన్ write the signs or the what's the plus and minus in the each quadrant. First quadrant లో plus plus ఉంటుంది, సెకండ్ quadrant లో minus plus, థర్డ్ quadrant లో minus minus, and fourth quadrant లో plus minus. You need to remember this is 0 that is represented with O, 0 comma 0, 0 comma 0. Okay, example, there is a road network. మీ గల్లీ ఉందనుకోండి, ఇక్కడ బిల్డింగ్ ఉంది, ఇక్కడ బిల్డింగ్ ఉంది, ఇట్లా రోడ్లు ఉన్నాయి. ఓకే, ఫర్ ఎగ్జాంపుల్ I am taking this is a 0 point, 0 kilometer reading. From here I consider it as 0 kilometer reading. Okay, now from here to here, for example, it is 1 kilometer. It is 1 kilometer. When we are taking from here it is from here to here 0.5 kilometer, for example. And another thing, here till here to here another 0.5 kilometer. Here to here this is also 0.5 kilometer. Okay, that line diagram I am drawing here. Here see, let us 1 kilometer, 0.5 kilometer. This is taken as A house, B house. That means on the road. Just consider it is. This is also 0.5 kilometer. C, you can say this is C, this is D, this is E. This is 0.5 kilometer. Okay, in the graph I told to you, that is x and y axis are there. On every place at the center O 0 comma 0, that is x and y. X and y as 0 comma 0. For example, here 1 is there, 2 is there, 3 is there. Here 1 is there, 2 is there, 3 is there. On the x axis 1, y axis 1, both are meeting at one point. This one, both one point meeting at one place. This is what? X axis 1, y axis 1. On the x axis 1, y axis also 1. This is the representation of the exact location of the point. Okay na? Representation of the location of the point. Location of the point. Okay na? Representation of the exact location, we can say exact or the location of the point. ఆ పాయింట్ లొకేషన్ ఎక్కడ ఉంది అనేది మనం రిప్రజెంట్ చేయడానికి కామన్గా మనకు గూగుల్ మ్యాప్స్లో కూడా చూపిస్తుంది. లాటిట్యూడ్, లాంగిట్యూడ్ అని చూపిస్తుంది కదా, లాటిట్యూడ్స్ అండ్ లాంగిట్యూడ్స్ ఏ విధంగా ఉంది ఆన్ ద ప్లేన్. ఓకే, లైక్ దట్ హియర్ దిస్ ఈజ్ x0 y0 అనుకుంటున్నా. ఇక్కడ స్టార్టింగ్ ఇక్కడికి వచ్చేసరికి ఏమవుతుంది, x డిస్టెన్స్ ఈజ్ 1 కిలోమీటర్ పెరిగింది, బట్ y డిస్టెన్స్ పెరిగిందా? పైకి ఏమైనా పోయినావా? పైకి కిందకి పోలే, సో 0. నెక్స్ట్ ఇక్కడికి వచ్చేసరికి ఏమైంది, ఇక్కడ x డిస్టెన్స్ ఈజ్ సేమ్, ఇక్కడి నుంచెలే పోయినాం మనం 1. వాట్ ఈజ్ y డిస్టెన్స్? y సైడ్ వెళ్ళినాం మనం, y యాక్సిస్కి 0.5. Okay, next for the D, what is the point of the D? 1 here is the x is 1. What is x distance పెరిగింది, ఎంత పెరిగింది? 0.5. 1 0.5 1.5. y ఏమన్నా పెరిగిందా? పెరగలే. ఫ్రమ్ ద స్టార్టింగ్ వీ నీడ్ టు టేక్ ఇట్ యాజ్ ఎ రిఫరెన్స్ పాయింట్. దిస్ సెంటర్ ఈస్ ద రిఫరెన్స్ పాయింట్. స్టార్టింగ్ నుంచి ఏమన్నా పెరిగిందా? పెరగలే. సో 0. Now here D point D is there. 1.5 is the x distance. ఈ నుంచి ఇడికి 1.5 కిలోమీటర్స్ ఉంది నాన్న. సో x ఏమన్నా మారిందా? మారలే. x డిస్టెన్స్ గంతే ఉంది 1.5. y మారిందా? మారింది. y మారిందా? మారింది. ఎంత మారింది? 0.5. ఎక్కడ పోయింది? కిందికా పైకా? కిందికి. ఫ్రమ్ ద రిఫరెన్స్ పాయింట్ కిందికి పోయింది. పైకి పోతే ప్లస్, కిందికి పోతే మైనస్. ఇక్కడ చెప్పినా కదా, పైకి ప్లస్, కిందికి మైనస్, ముందుకు ప్లస్, వెనకకు మైనస్. ఓకే, రిమెంబర్ దిస్ వన్. నౌ హియర్ మైనస్ 0.5, మైనస్ 0.5, మైనస్ 0.5. This is the exact representation of the location of the point in the graphs or the plans. Okay, this is very most important. We need to thoroughly with practical examinations or the practical analysis. Okay, the practical knowledge is important on these topics. Okay, now we can represent this 0, 0, 1, 0.5, 1.5, 0, 1.5, 0.5 on the graph sheet. Then we can write the like this lines. Then we can see the plan, how the road will be, and where is the exact location of the house or the exact location of the any room or the any industrial park or any shop we can find out. Okay, like that is completely calculated in the Google. You can see in the maps. Okay, this is most important. On tomorrow then we will start with the polynomials, most important. And if you are very phenomenal in that graph, if you are enough, okay, if you are good enough knowledge in the graphs, what I told you in the last half an hour, this is most important. This is useful for 4 to 5 chapters in the mathematics. If you are very exceptional in these topics, then you will excel 4 to 5 chapters in the 10th class mathematics. Okay, please share this opportunity to the everyone who are preparing for the 10th class. Almost 3 to 4 chapters are completed. Please listen total complete video. You will understand mathematics better. You will get the more marks in the final exam. This is the best opportunity for the 10th class student. Please utilize and share to the every student. Okay, this is simply 30 days classes, and on the final we will take the master classes. Okay, so that utilize this chance to everyone. Thank you.